How about now? No audio. Give it a moment. Come on. We'll tell Twitch. New camera. Who dis? Oh, I'm not logged in. I was going to ask you. New camera. Who dis? Okay. So what I was rambling about was I bought a new camera. So hopefully you can see my amazing face now. Let me know if it is garbage and I can buy an old camera. Okay, so I'm pretty sure today is October 17th, 2024 here at ASU. We are here in CSE466, and over break, you are assigned program exploitation, which is kind of like a midterm module, right? It's a cumulative module. Shouldn't be any like brand new concepts really being thrown at you. For the most part, it should just be cleverly applying concepts that you have already seen. So, memes. I think people in the end kind of liked the heap. At the beginning, I think people didn't like the heap. But I think you came around on you after you understood how it worked. I like this one. All right. It's hard to see. The font's a little smaller, but the next pointer is the same on all of these, right? And so results are meeting expectations. I don't know. We got a whole bunch of the same thing apparently in the TCAS, right? That was clever. I liked it. This one here made me think of a different module that historically has been taught in CSE 598, where we specifically try and look at exactly this. How do you, if I'm given like a heap arbitrary read, how do I turn that into a stack leak? Or how do I turn that into a libc leak? Or how do I jump around and pivot it around memory, right? And it's definitely something you have to deal with in this module. It's just not something we specifically call out and make a critical point. I may or may not bring this down into 466 at some point. What do we got here? BB Heap level 20. I think, out of curiosity, people here, who solved like 1920? 1920? Anyone? But
just 19.
You got, okay, 19 halfway? Okay, but like hopefully those that gave 20 a good effort, like you had some fun with it because you saw what I was doing to you, right? The last 4 challenges were definitely not easy, but I think if you enjoy this type of stuff, they're definitely fun. They're like the little sub problems that were specifically baked in there. Like one of them in earlier levels is the non-printable characters. I'm not white space armoring anything for you. It was just like this happy accident. It was like, oh, well, that's great. Let's see if you can figure it out. Consistently, we'll do this. And this will happen for this entire course. And if you decide to continue working in this area, you'll make the same mistakes over and over again. And it'll hurt, and it'll be a waste of time, and it'll suck, and you'll feel bad. And eventually, you'll remember all of the things that have to be right. A good example, if you're stealing something from the help text, okay, that's great. Not going to work in the point 1. You know that. Why'd you do it? For whatever reason, we still love brute forcing. I don't know what I blame. Like every class that I teach, we just brute force is not the answer, man. Okay, if that's the only tool in your toolbox, like everything isn't a nail. You can be a lot more strategic, as you all know, and I preach by using something like GDB. Yeah. Boom. All right, Twitch. I can see you today. So here's slide 1. Wait for the delay. Maybe. Why does technology not work? Okay. Slide 1. Just going to update on Twitch now. That's slide 2. Nothing's going to get done today, I know it. Everyone likes to brute force stuff. You don't have to. Like 9 times out of 10, you can answer the question or the thing that you're stuck on by using GDB and using GDB, I'll say, intelligently. There's definitely many ways to use GDB that aren't answering the question that you have. Program exploitation. So people looked ahead here and like, hey, big spooky thing, because this is not a baby level as far as the challenge design. They are prefixed with toddler. Similarly, system exploitation is toddler as well, because it's a cumulative thing. Hopefully you started with kind of these baby concepts of exploitation, and now you're going to have to apply them in a less obvious content. Apparently, some people like burn through the checkpoint, right? That's a good sign to me. This is, as I said, there shouldn't be a whole lot of new concepts. I saw in the Discord, some people said that like halfway through, it like suddenly jumps up. I don't know if that is the case, if there's something that people are hard stuck on. I'm just going to guess that's where like Yan85 starts appearing. Because we should love Yan85 and Yan85 instructions. We're past the deadline, but I did like that name because you simultaneously were trying to finish up Baby Heap while dealing with the exploitation stuff being assigned. And Yan85 is there. And then one of the things, it says program exploitation Yan85. Furthest back is Yan64, which is a thing that's not made up. That is waiting for you at the end of the current challenge set. So does anyone know why Yan85 is 85?
I was going to ask 32-bit.
So it's a rip off of the 8086 processor, which is actually a 8-bit processor. Yeah, I think it's Jan's birthdays, 1985. Is why I see Yan 85. But it would make sense, right? When we say Yan 85, we think of x86, which is a 32-bit processor, but the Yan85 VM is 8 bits, right? How many bits do you think Yan86 is, or Yan64 is? 64 bits.
I'm jumping between 16 and 64.
What's that?
Right. I was thinking it's either 64 or 16 because you're doubling the.
Okay. So yeah, if you didn't know, like it would be okay, we're doubling. Maybe Yan64 is really 16 bits, and we just say, yeah, screw it. Bigger number. But no, it is actually a 64-bit Yan VM implementation. So, course schedule. We are done with like pretty much first half, right? If you made it this far, hopefully you're feeling pretty good about it. You should feel pretty good about it, right? We're halfway there. So we're on our 5th module. There's 5 more. We're at the halfway point. We are going to proceed as scheduled. Someone says 7.0 is a 1 billion% jump in difficulty because of Yan85. That is a big percentage jump. All right, like I don't know who it was, but someone on the Discord told me it was physically impossible to run a challenge last night. And like I threw a sentence out and then it was suddenly cured. I bet you that with a little bit of like stepping back and first principles, hopefully you wrote that assembler or disassembler that was suggested back in Baby Rev. Yan85 isn't that scary. So there's our full course schedule, right? I just haven't had this on a slide deck in a while. And so people were looking back at the intro slides. No, nothing's actually changed here. So grades, how'd we do? Misuse, dynamic allocator misuse, solve rate. Yeah. Looks okay to me. Looks as you'd generally expect. It is nice to see that there are very few people starting over here on the weekends now. There's still some people that started earlier that may have not made it very far, but generally speaking, no one is waiting on the very end. Solve distribution. This is specifically for the heap module. here's what we see. I'm pretty happy with that. Where are most people? Most people are over here at 60% or more, with most people completing everything. So looks good to me. Course grades. Now this is including extra credit, or prior ones were not. I think that's worth noting if you're comparing these two graphs. This one, and it has to do with how, because you can't get more than 100% on an individual module. So when I bucket this into a histogram of 10 buckets, the highest thing that one could get on a module is 100%. That makes sense. However, since this course grade distribution is including extra credit, these are not bucketed at clear 10% increments, because I think the highest grade in the class is 108%, I think right now. And so that is the upper end here. So that means that each one of these buckets are like 12%, give or take. But again, pretty happy distribution. Again, I'm only counting people who solved at least one thing in the current module. And by and large, most people are plugging along. Looks good to me. Anyone disagree? Think this is like horrifically? Yeah, we're cruising. All right. Mean points. One of the things that apparently some people are very passionate about is what is the definition of a week? I don't know who I'm arguing with, but this is, they're like discussing this with, but this has gone to like an insane degree at this point, as far as I'm concerned. I don't know who it is. And it's probably for the best that I don't. There were suggestions that I change right now. I know what the webpage currently displays, and it shows, I think, Wednesdays. It's actually Tuesdays, because time zones are hard. Okay, it was what it was doing, and it's still doing right now, because I haven't merged in my PR. It was 6 p.m. on Tuesday is when the weeks were reset, which Arizona is UTC -7. You had 7 hours. That shows up as Wednesday when I turn that into a date, because it's still in UTC. Right? Fun fact. You can look at the PR if you want to see all of the fun details. So previously it was starting and ending at 6 p.m. No matter what I do, okay, it will negatively impact some students. And you'll be like, oh no, it doesn't. I've looked at what happens if I give all of you 0.5%. Turns out that would be unfair. I've looked at what if I roll it back a week? Well, that's going to be more than 16 weeks. That would be unfair. I've looked at what if I move it back to Sunday? You'd be like, or Sunday or Monday, right? Something that someone would think is the beginning of the week. Makes sense. There's about 50 students who would gain an extra 0.5% extra credit. There's also about, I think it's 38 students that would lose 0.5% extra credit. And in my opinion, there's like, I don't care who wins or loses there, right? I don't have a horse in the race. I just need to be like fair and consistent about it. Now, one thing that should be fair and consistent is 6 p.m. is like this arbitrary time to draw the line. I agree with you there. And so whenever I'm merging this PR, should be later tonight. That'll get moved. So Tuesday is Monday at midnight is technically when everything resets. Okay. That aligns with when the assignments go out. That aligns with exactly 16 weeks. Or not when the assignments go out, but when the first lecture of a topic occurred, right? We launch on Friday. First class is the following Tuesday. So we reset at Monday at midnight. All right, there's some new topic or new thing that the class is focused on that you can meme and dunk on, right? That makes sense to me. Ultimately, this change, where I decide a week begins, is a 0.5% extra credit difference, right? Unless you're doing like some weird thing where I'm posting, so I'm assuming that you're posting on like a semi-regular schedule, right? If you're posting on like a Tuesday, then on like a Friday, actually that would still be the same on this, right? Like there's a very specific scenario where you could post on like a Sunday and then a Thursday, or a Sunday and then a Monday, or yeah, I don't know. You could do it. So you exactly straddled that. You were thinking that it reset on a particular day and you were trying to straddle that and be clever. Well, it turns out you're just a victim of your own cleverness. All right. Like I don't have a lot of sympathy there. Like in spirit, you're posting once a week, and once a week is once a week, not 2 days, right next to each other. Now, like I said, there's still some people who hypothetically lost 0.5% extra credit by me making this ruling. All right? I don't think this is going to be a big deal. If, at the end of the semester, you're 0.5% away from a grade cutoff, it's going to be the difference between a B plus and an A minus, and my gosh, you need that A minus. You can send me a DM at the end of class, be like, hey, I'm done working on stuff. I think I lost that 0.5%, and that is going to make or break my academic career. All right, you can send me a DM. I have a list of the accounts that are impacted negatively by this, and if you're like, I really need that, and you're one of those people, I'll make it right. The goal is not to harm anyone or hurt anyone's grade. We're supposed to like have fun, get some extra credit. It's supposed to be pretty chill, honestly. And this past week, thinking about memes and weeks and all of the different permutations of ways I could deal with this, which I came up with like 10 different solutions. And there was none that were actually like net positive for everyone. It has not been chill, right? It is not what I wanted to spend a good part of my time on. But I did put in the effort. Oh, and I also transcribed every single video, just for the record. I transcribed every single YouTube video from every single class, and I never said that it starts on Mondays. The closest thing I said is that it specifically does not start on Mondays, and it's going to be like some flex thing, but it was like a hand-wavy, arbitrary, whatever. So there's nothing to hold me to there. And if you find something otherwise, I'm going to blame the transcription service. But I also did put in effort to try and hold myself accountable to whatever it is that people are remembering. So I did put an effort on those fronts. Okay. Course grade. Class average without extra credits like a 75.21. So that's what, a mid C. Class average with extra credit is a 78.98. It's actually kind of disappointing. Why is it disappointing? Because we just got done spending like 5 minutes, 10 minutes talking about freaking memes and weeks and where we can draw this line over 0.5% extra credit. You know what the average student who's actively solving challenges on this course has done? They posted 2.5 memes. There's been 8 weeks. Okay? That could be 4% in the upper end. If people were actually posting memes on a regular basis in this class that were getting liked, that number should be at least 2, probably 3 or higher. This is free extra credit for posting some really low effort meme that is somewhat relevant. You can literally type into Google meme generator, pick some template, put Rob Was GDB, right, and upload it there, and you have like a non-zero chance that I'm going to like it. Now don't do that, because now I specifically won't, but the point is the bar is pretty low. And so for us to have this great discussion about, oh my gosh, what am I going to do? When are the weeks end? I'm trying to metagame as a class. People aren't doing that, all right? So I don't think this is going to really be a big deal. Similarly, help extra credit goes up to 5%. Average person here has 0.9, and that is really just like a couple extreme helpers, and most people just don't try at all. It is worth posting. That's like what? We did the math a week ago. One was worth like 0.86 or something, right?
0.8.
0.89. All right, you remember, I don't. So that means that the average person in this class has said one helpful thing. Okay, 2 helpful things would give you as much like extra credit, if not more, than posting a meme. So like, guys, use the extra credit. I don't know what's wrong with you. I'm telling you, I'm not going to curve this class. Here's some free points. All right. Logistics. The next module listed on the course schedule that I just showed like 3 times is kernel. I may or may not change that. The reason that I may or may not change that is I'm trying to make it so that the experience sucks less for you. So doing kernel exploitation requires that the challenges all run inside of a VM, because you need to exploit a kernel and you're not going to exploit the kernel that the actual infrastructure runs on, right? So I need to, all the challenges run inside of VMs. Earlier today, I helped install a new server that is specifically intended to be used for these kernel exploitation related things. And it has newer hardware that should make kernel VMs, the kernel challenges in the VMs, not be as slow as molasses. The kind of caveat there is great. There's a new server. It's somewhere in a data center. There needs to be changes to infrastructure code so that I can route people to the right box, things like that. That may or may not get done in the next week. And then additionally, for the kernel module in particular, one of the benefits of having this newer hardware is this newer hardware supports some security mechanisms that it would be great for us to explore and or discuss. So depending upon how much of that stuff gets done by next week, Friday, if that all gets done, we'll launch kernel as intended. If not, it'll be, I don't know, race condition sandboxing. I could do either one. Maybe sandboxing. I like sandboxing. But yeah, all three of these, kernel, race, and sandbox, are all listed as 1 week. And there isn't a direct dependency on any of them, as far as I recall. So that means that I could flip any of them. New program exploitation challenges. I've designed 2. I have 2 more that I want to make. That'd be 8 challenges, 8 more challenges total, being a 0.0 and a 0.1. We'll see. It's not going to mess up your checkpoint either way. So whatever the checkpoint number is, if the checkpoint is what, 11? Okay. Me adding challenges is not going to change the checkpoint. But you may get some new challenges thrown on there. What's up?
The total number of challenges in program exploitation now is 11.0 to 11.1.
Correct.
It says 23.6.
Ah, that's because, 11 times 2 is 22. So that would be what, 12.0 to, see if I can math, 19, 20, something like that. Right? Maybe 2, 4, no, it's going to be 4, 15. All right. It'd be cooler if I did that, right? But I don't think I can make that many interesting challenges by the end of this week. But I do know where they're going. They are going to get tacked onto the end. They are not things that are going to be easier. They're things that are going to be harder, right? Think very similar to how I added safe linking to the heap stuff. But it'll be something fun. Okay. Any questions on logistics, class, course, schedule, grades, extra credit, any of that good stuff? Any chance you get a new module too? You asking for more work? New modules are coming out in 365. I don't think there's going to be any whole new modules for 466. There may just be content getting reworked. All right, with that, I have no plans. As I said, I spent like the first half of my day in a greatly air-conditioned, which was amazing, data center. So I didn't have time to like throw together a specific demo. 2 things I heard on the Discord. What is an intra-frame overflow? And then something about breaking out of Yan85 VMs that I'm not entirely sure what was being asked. Anyone here have something in particular they're stuck on, they're interested in? So this is kind of, I don't need to demo anything because it's a cumulative module, so the concepts you should already have, right? Like I don't need to show you how to reverse engineer. There was a reverse engineering module. I don't need to show you how memory corruption works. You did that, right? It's just about where is the correct context to apply them. Does anyone here have something they want to hit me with? All right.
So when I'm running 0.1, the challenges with 0.1, which have no debug information like main or challenge or any method names. If I want to break somewhere, like after the program puts like welcome to challenge something, if I want to break that, is there anything I can do instead of just catch syscall puts and going through all
that? Sounds like pain. Yes. So for Twitch, the question was the 0.1 challenges are stripped, which means there are no symbols, and that means when I GDB this sucks because I'm using things like catch syscall to try and
That
like,
never worked for me till now.
what's that?
That cat syscall thing, I never landed on the main method or the shallow method. I just landed somewhere.
Yeah, that's because like syscalls are different, right? Like catching a syscall is catching the actual syscall, right? Where we're like main, is main a syscall? No. So like you can't catch syscall main because it's not a syscall.
I mean, I
Right?
can't even backtrack to main after I catch it.
I can't go anywhere. I don't know where I am. It's just a mess. Yeah. The question is like, how do I deal with these strict binaries, right? Is there a better way? And the answer is always yes. Doesn't mean I know it, but in this case I do. So I can show you how to deal with strict binaries. The other hand I had.
I didn't finish all the modules previously. Like I made like let's say about 80% of most of them.
Hmm.
So is there anything after 80% that I didn't know going to affect me in this module?
Okay, the statement for Twitch is I didn't finish 100% of the modules that came before. I finished, say, 80% of them. How is that going to affect me moving through the current modules here that's cumulative? So I can't say for certain because I don't know what you like where the 80% cutoff is on everything. But I would say as a general design principle, you should have all of the tools at 80%, you should have all of the tools to solve these challenges, right? Keep in mind that for most of these modules, the last like 2 or 3 levels are stretch goals. They aren't necessarily intended for the average student to solve, which means that I'm not going to like hide something that was in level baby heap level 20, and I'm going to include that in this cumulative module, right? You probably have all of the knowledge. Most of these challenges, these cumulative challenges, literally are like taking parts of things that were used in earlier levels, right? And so the like concepts or pieces of the program, you should recognize to some degree, right? Like, hey, I've seen this before. How can I use this in this binary, right? Because these ones aren't going to tell you, oh, I'm reading in, whatever. Now you can overwrite my saved return address. Oh, you're too far away, right? This is supposed to be, a bit more like an exam. There's still a 0.0 and a 0.1. But 80%, if you solved 80% of all the prior modules, you should have everything you need to solve these, right? The trick here for these cumulative things, particularly with like the comment that the first Yan85 one is this insane jump, right? You need to reverse the binaries. Okay, I don't know how people are doing this without reversing binaries. And this goes not only for like the cumulative modules, but just in general. Your first step, I do not preach IDA, but your first step should be open the binary in IDA, run it a few times on the terminal, get a mental model of how this thing works, look at what's going on in the decompilation, and be like, what's interesting? Like, if you aren't doing that step, you've like bricked yourself. Because then you don't know, what am I trying to do, right? As a cumulative module, figuring out where is the memory corruption is part of the challenge, right? And how do you figure out where memory corruption is? You're going to reverse the binary. You're going to throw in a whole bunch of input and see what seg faults. You're going to just try some stuff. But as far as the core skills, 80% you should have enough. All right.
I have a question.
Please.
Involving Yan85. Is it possible to make Yan85 code do a syscall it's not designed to do? Because I know there's only a couple like open read and write. Is it possible for Yan code to perform a chmod, for example? Or is it only the syscalls we see?
So this is something that you should be able to pretty straightforward figure out. But by doing exactly what I described, we'll do it right now, and we'll think about it. Okay. So we'll do that. We'll plug in some GDB. We'll talk about some overflows. Yeah, all right. I think we got enough to fill the time. Unless Twitch has anything particularly spicy. So hopefully this is a Yan85 level. I just kind of arbitrarily chose it. Because it's one of the later ones. Okay, so this binary says see if I can use a computer today. I'm going to do exactly what I described there. This challenge is a custom emulator, emulates completely custom architecture Yan85. Hey, I've seen this before in Rev. It's a full Yan85 emulator. We have to reason about Yan code. This time I'm in control. It doesn't allow us to call open via the sys instruction, but luckily it makes a memory error that will let us accomplish our goal. I don't know if this is the level that you're particularly on, but we're going to use it as a, yeah, we're going to use it as a standard, all right? Cool. We see here it's going to call read up to hex 300 bytes into this buffer. What's a question I may want to ask right now? Okay, is there a buffer overflow? I don't know if there is or isn't, but this is, yeah, you're making a weird face at me.
But this is a Yan85 challenge, right? So even if we do a buffer overflow, we still have to, I mean, the overflow thing has to be x86 not Yan85. Again, this is my
Is it okay? I'm going to ask that you repeat that because you said a few things that I don't know which ones I want to correct.
Okay. So if we do a buffer overflow, that means we are modifying something existing in the stack. So which would be x86-64 in this case. But we are dealing with Yan85, this challenge. So is buffer overflow really appropriate here?
Fact. So the question is you know, there are a few things kind of baked into that question. But the first one is, okay, this is a buffer overflow. If I were to, like hypothetically, right? Hypothetically, if this were a buffer overflow, what would I be overflowing onto, right? Well, okay, I'd be overflowing on the stack, on the x86 stack, because this is in fact an x86 binary, right? AMD64. One of the things I would probably want to know if I was thinking, and I should have probably done this early, bless you, is there a canary, right? Because if there was a buffer overflow, a canary on the stack, the existence of a canary would influence whether I could or could not do this, right? Now, the other statement was, this is a Yan85 challenge. So do I need to buffer, or do I need to overflow Yan85 stack? Or is this x86, or what am I dealing with here, right? And I think people get a little bit confused when they're thinking about this stuff. And it's why there was this question on Discord, like, how do I break out of the VM? Like, the VM is just an x86 binary, right? But we don't know what the vulnerability is, right? They said there was memory corruption. There's a buffer overflow, and does that lead to memory corruption? Yeah, okay. I don't know where the vulnerability is. This is a 0.0. That was as much help as I'm going to get, right? I run this thing, I give it some bytes. It's going to take a look at the stack, okay? What stack is this? Is this an x86 stack? Is this a Yan85 stack? Oh, no, what's going on here?
X86.
It's an x86 stack, right? We haven't like severely done anything crazy here. We're referencing via RSP. This is the same type of printout you've seen before. We're looking at the stack. We're still just thinking about the x86 binary. All right. It's interesting that the challenge chooses to show me the stack, though, right? Because that kind of implies that, hey, maybe the stack is something I want to look at. It tells me the saved frame pointer. It tells me the saved return address. I hope this really isn't a buffer overflow right there, because I like just arbitrarily was like, let's talk about that. That would be funny though. And then it tells me my return address. Okay. It says it's a teaching challenge, and then it starts to try and interpret whatever garbage I typed as Yan85 bytes and prints it out. Right? Is there a clear path for what I need to exploit here? No. So should I just like keep banging away on this? Should I start writing Python? No, I need to like think about what am I trying to do? And that brings me back to, okay, well, what am I trying to do? What could I do? What can I do? Well, one thing I'm aware of is buffer overflows are a type of memory corruption. Please don't read the actual full. So we're reading up to hex 300 bytes into a buffer from standard in, right? If we click on buff and we scroll up, we'll see how big buff is. That's a number. Is that a bigger number or a smaller number? How can I change it so I'm sure? So this is buff. I need to make this, the other one was hex. So, don't I hit X? No, X is cross-reference. How do I make this hexadecimal? IDA. H? Capital H. Okay. I'm incapable of using IDA. This is why I am a GDB bro. Okay. So the buffer is hex 400 in size, and it reads in hex 300. Good, we're safe. Okay, so there is not a buffer overflow there. Okay, but there could have been, right? And we have to make that check to figure out, well, where is the vulnerability, right? That's how we need to be thinking about this in these cumulative modules, because they aren't telling you what the plan of attack is, right? That very well could have been the case and may be the case in one of these. All right. Is there anything else here that looks interesting? Okay. We've seen interpreter loops, so we can go in there. It's interesting that that still shows that prints out the stack. We'll go with it. All right. So we have interpreter loop, which calls interpret instruction. We've probably seen this already from baby rev. All right. We're interested in, to circle back, can I make Yan85 do a syscall that is not what it intends, right? I think a safe assumption is going to be that we want to look at how does Yan85 implement syscalls, right? And what we see here is that there is a switch, right, that's going to determine what the instruction is. We want the interpret sys. There's going to be some other byte. In this case, looks like whatever A2 is. That byte is determining which one of these branches we go into. And we aren't, like this call to read, is this a literal syscall byte, like instruction? Do you see the word syscall on my screen? No. So it's not a literal syscall instruction. What is this calling into? It's calling into a libc wrapper, right? In general, back in shellcoding, we wrote shellcode that had the literal syscall instruction in it, right? In the x86 assembly. This isn't a literal syscall instruction. What the Yan85 VM is doing here is it is calling read. Where's read located? And yeah, it's in libc, right? And so it's going to call libc. Libc is then going to have the literal syscall x86 instruction. Now, if there were, just hypothetically, as we're kind of like thinking about the problem space here, if there was a literal syscall instruction here, then RAX would determine what syscall is actually executed, right? And so we could influence RAX, and that would determine what syscall was actually executed. But that's not what we see here. Instead, what we see is that it's calling into libc and it's calling read. And so I can't influence really what it calls here, right? If we go a little bit lower, we see read memory, we see write. And if we go into the implementation here, again, these are going into some other function. They aren't performing a raw syscall. So there isn't a path here in just like a simple memory corruption sense of some memory location or some value that we could corrupt that would influence what syscall is actually executed, right? Instead, it's just going to call a function conditionally based upon the value that is in A2. So what is your goal? Your question was, can I trigger a syscall that it just doesn't intend? It doesn't look like it as far as like, we have to trigger some functionality that exists in the binary. Can you restate what you're trying to do?
Well, no, I'll just have a different pattern where I would try now. I would see where, since we're trying to give it some shellcode, can I put a shellcode into memory? Can I read it from there? Is what I'm thinking right now.
Can I?
I'm thinking I'll just use the existing syscalls that are available to basically solve the challenge.
Yeah, if we take the challenge at face value, right? Does it have open? Does it have read? Does it have write?
It doesn't have open.
It doesn't have open. Okay, so if that's our barrier here, how can we address that?
Try using the other syscalls somehow.
Okay. Did you guys need something?
We actually have this room at 5.
I find that that's got to be a scheduling conflict, because I have this room every Tuesday and Thursday from 4:30 until like 5:45.
Really?
Yeah.
Yeah, we have an event in here at 6. So let me ask Leo.
Okay.
Okay, I'll be right back.
So what does open, read, write use? What do they work on? Like, why do I need open? I need a file descriptor.
Yeah.
Right? Can I get a file descriptor some way other than calling open in this binary? I don't know that this is the intended solution. We're just like talking here. What do we know about file descriptors?
Comes to mind right
All right. Are file descriptors inherited? Would be a good
now.
question.
You could, yeah.
File descriptors are inherited. I was talking a little bit, someone hit me with, I don't know if it was this challenge or not, but a question about file descriptors. And so if I cat proc self, or not cat, well, ls-l, fds, right? This is a thing. Proc self, it's fd, not fds. This gives me a listing of open file descriptors in the current running process, right? But what is the current running process that's looking at this when I run this command? Is it bash?
ls.
It's actually ls, right? Which is like this weird meta thing when you're thinking about using proc self. Now, I happen to know in bash, let's do 367. I can do this. And what I've done, this is like some bash wizardry. You don't have to know it. But what this has done is this is opened the file descriptor on 367. And it is open for read and write, which is why I get the diamond. And it is opening to temp my secret file. I'm not saying that this is useful or what you need to do in this challenge. It's just a discussion on file descriptors. And if I run ls-l proc self secret file again, we see that ls has inherited this file descriptor. And so now it has 367 pointing to my secret file. Did ls have to do anything to get that? No. They just got it for free. Now, one of the things that is very likely to be a comment, I'm just like predicting the future here, is what happens if I do this? I get permission denied, right? Because who's opening the flag file? Bash. That's actually exec. Maybe my font's a little bit too small. Exec's a scary thing to run in bash. Because it's the equivalent calling like exec VE. So like if you just exec ls, your terminal will likely disappear because you've turned bash into ls, which will then write the standard out. And then when it's done, it exits. So then your terminal exits. I don't know why you have to use exec. It's like a ridiculous bash thing. Exec is the command to do this. Because if you like typo it, you'll just lose your terminal. But yeah, bash is the one that's doing this, and bash doesn't have permission to open the flag file. Right. So you can do that. You can make file descriptors be available in child processes. if you have permission to open. That's something I would consider here. Yes.
Are file descriptors like a global thing?
The question is, are file descriptors a global thing? The answer is no. We can poke a little bit more at this when we get into kernel. But the way that this file descriptors are literally just numbers, right? They're ifs. Every running process has inside of the kernel something that's called a cast struct. You don't have to know what this thing looks like. It's just a whole bunch of information the kernel has on a process, right? One of the things that is on this task struct is a list of open file descriptors. All it is a mapping of what number goes to what file, all right? And so when you like fork, what are you doing? Well, you're creating a column. No, you're creating a new process, but you have the exact same properties as your current process, right? And so no, they aren't global, but they're inherited from parent to child because you can copy that task struct. And so we want file descriptors to be inherited from parent to child. Right? It makes sense when you think about things like pipe, right? If I want to use a pipe to communicate from parent to child, I make the pipe in the parent, but I need the child to be able to interact with it. So, okay. Problem here is this thing doesn't call open. Does it call open anywhere? Well, that's not what I want. Let's do this. Nope. It definitely does not call open. So when I searched here, this showed me having functions in libc, which was not very useful. But when I look at the dot, because we know the dot table, if it calls open, then the dot table would have an entry for open, and it doesn't. So like there's no way into libc here, or like direct clean path. Oh no, I touched a cable. Hypothetically, and I don't know that this is a path either, but if I really need to call open, do I have the ability to leak one of these? And then do I have the ability to direct control flow? Right, like a ROP scenario. Can I get a libc leak? And if I get any of these, then I could know where open is. I could try and overwrite a return address. I don't think that's the case for this challenge because none of these require ROP. I'll tell you that right now. So that's not, at least none of these ones that you have right now, right? So it's unlikely that that's the case, but it's something I would think about. And so that's how I would approach it and kind of reason about these questions. It's a good question, right? And the answer is there's a lot of things that one could do, but you have to look at the binary and be like, can I do it? Was that helpful thinking? I danced around it a bit. Maybe. Leads you in a direction. All right, I'll take it. All right. Now the other question here was stripped binaries. I broke Twitch when I touched the cable. Do not touch the cable. Bam. All right, the other question was, I have stripped binaries. How do I GDB? So this was hiding somewhere in one of the reverse engineering lectures. Or class, not a Yan stream, but in class. I bet I touched it. All right, where do we want GDB to go? Tell me, where are we going?
Right after the last put is like
We're going after puts?
18.
18. You want to go here? All right. So I put this in IDA. I see this number down here, 1BCA. What is that?
That's the offset from the L start.
Okay, that is correct. The statement was that's the offset into the ELF start. Why is that useful to me? Anyone that actually remembers what I said?
I guess I don't know. VM map it, get the base address at this offset.
Okay. So we have this like idea we could VM map this and this base address up there at 434,000. That's going to change. I could get that. I could add to it and I could find it. Right. But every time that I run this, is that going to be the same number? No, that's going to be pain. I'm sorry?
Specify a base address in our GDP and use that specific base.
So there's a statement about specifying a base address in GDB. I don't know that functionality offhand. Does that work on setuid binaries? I bet not, because by default, GDB does not disable ASLR on setuid binaries. All right. So what happens if I copy this challenge into temp? Is my copy a setuid binary? Okay. So what happens if I GDB this copy? That's a pretty consistent number, isn't it? We've seen that one before. If I run this again, do I get the same number? Yes, I do. Okay, so now my math has at least gotten to a consistent number, right? That's good. The other thing I could do is in my GDB init, I have this third line here. It says set $base equals, and then it has that number. I could probably use like this set base functionality of GDB, right? I'm going to do the reverse. I'm just going to say, as long as it's not setuid, I know what it is. All right. Now someone's starting to smile. I think they see where we're going here. So I'm going to GDB on my copy. Where do I want to set my breakpoint? Base plus 1 BCA. Oh, what did I do? Did I not start?
I don't think you need the star.
Okay. Oh, I didn't. Okay. I believe in all capitals. There we go. Star included. I'm claiming that that is where it's going to be. Is that your line? All right, we got there. And all of a sudden, dealing with strict binaries is less pain, right? The key here was to allow GDB to disable randomization, and then take advantage of the fact that the de-randomized base address is something that we know, and we can set that as a variable in our GDB init, so it's just always there for us.
Can I set the base to just 0?
We'd have to ask in the back, how do I set the base address?
You gave us the magic address. I was talking about that GDB init address.
Oh, okay. I thought you were saying there was some magic GDB command to literally base the ELF somewhere. And I was like that would be crazy. Like I could see maybe GDB could do it, because GDB can do anything, but it's not wizardry I'm aware of. So.
And this base address is just for the binary and the heap. That's it.
It would be for anything that is contiguous from this memory address. So we look here, all right, 5,000, 5,000, 5,000, 56,000, 57, 57, 58, 58, 59, 59, 7A. Okay, so yeah, it would be to there. That would work. But generally speaking, what we want to do is we want to use it to set breakpoints, right? Because what we're interested in is the text section, which is going to be this region. That's why we use it. Hypothetically, you could use the base address to access, for instance, something in like the BSS, which would be this region. That'd be a little bit silly, in my opinion, for GDB purposes, Because like at that point, if I want to do something like that, I'd start scripting and I'd have Pwn tools. I'd load an elf object and I'd start playing that way instead of using GDB directly. But you could. The other thing here, which I don't believe I showed, but we'll give it a shot. We'll see if we can do it. Because it's typically that's what I do is I copy into temp, right? There is another way. We already have it, or we have something. We'll move do.py to be, I think we're at 3, and we'll make a new do.py. Okay. We'll import Pwn tools. Normally we'd say like p equals GDB debug challenge toddler 1 level 8.1. Right, and we do this. And then a very important thing is to end your scripts with p interactive. It doesn't have to be p interactive, but I highly encourage p interactive because it's just going to solve foot guns for you. All right. And if I run this, what'll happen? It's not random, it's randomized. Why?
So we use the set UID.
I'll use the set UID binary, right? So I'm gonna have to cheat here. We could look at Pwn tools documentation, but I'm going to use the debugger or the interactive debugger here. Is it going to show me what I want? Yes. There's 2 arguments here that I can pass to process that are interesting to me, right? The first is set UID and the second is ASLR. So GDB will not disable ASLR on a set UID binary. So I want it to not be set UID. And then what I really want is to disable ASLR. So let's say ASLR false. Look, I did the exact same thing, but now I'm starting it from Pwn tools.
Why do we need to disable ASLR? Because
What is the functionality that randomizes addresses?
but when we run GDB on a, let's say, a copy of a 0.1 binary, ASLR is enabled even then, right?
You're saying if I run GDB on a non-set UID binary,
Yes.
so ASLR is enabled on the system, but GDB will disable ASLR
Oh,
by default.
command line GDB will disable it.
Yes, command line GDB will disable ASLR for non-set UID binaries. Jan's lecture videos, the pre-recorded ones, when I want to say memory corruption, when he talks about ASLR, he shows how to do it just in bash, right? You can run, I don't know, it's a PR control command, 'cause it's not something I typically do, but you can start up a shell that just disables ASLR for that shell. Probably requires root, because otherwise that would be OP, right? And so this is how I prefer to deal with it, right? Either just copy the binary if that makes sense, work on the non-set UID one, or if I'm doing some scripting and for whatever reason I want to be a fancy Python boy, I can do this as well. Does that get you everything you need for your stripped GDB awesomeness? All right. Let me take a quick look here at Twitch. I've got roughly 10 minutes left. What do we got here? Okay, you found my typo on the slides. Thank you for sharing. We certainly try. Copying it. Okay, the question is, with copying it to get rid of the ASLR, can you do that for all challenges, and will it give you the flag that, or does it need to be solved through the original challenge? So that's a reasonable question. Can you copy every binary? The answer is yes. Can you SCP every binary? The answer is yes. Can a non-set UID binary access the flag? No. Why? The flag is only openable by root. And if I copy the binary, it's not running as root because it's not set UID. And so there are challenges that, for instance, seed on the flag, right? They, at the very beginning, when they start up, they access this flag file and they need it to do some randomization, something like that. Yeah, if I copy the binary and it depends on that, it'll fail, right? I can't do anything there. But what can I do? I can use practice mode, right? I could copy the binary. I could then sudo chmod the flag. Like I can create a scenario where I can debug this behaving somewhat sane. I just need to understand what mechanisms are at work and address whatever the specific pain points are. All right, was there anything I said? Intraflame frame overflow. Did I address what you had? I don't remember what your question was.
Yes.
Yes? Okay, I just got to make sure. All right, I'm 3 for 3 there. We talked a little bit about Yan85 VMs. There isn't like an escape the VM, right? It's understand the implementation, find the bug. Is it a memory corruption bug? Is it a interpreting an unsigned int as an int, you know, like a type conversion bug? Is there a buffer overflow? There's got to be a buffer overflow in this, right? Like not this level, but like some of these have to have buffer overflows. There's no way we have a cumulative challenge that doesn't involve that. And so that's where it's find it. And that is part of the challenge there. So I don't want to get too crazy there. Question from Twitch here. This is how you disable ASLR in Linux via bash. Okay, so that's not what I was going for. That is not the command. So that I was thinking of. They were pointing out that inside proxys kernel randomized VA space, this number, because remember proc is a pseudo file system that the kernel exposes, it shows us 2. And if we were to look at man proc, this 2 implies that ASLR is fully enabled. It's going to randomize everything that it can. You can probably write to that variable to disable it at the kernel level, but there is another command. Maybe I'll look that up for next class. So you can just run on the shell. You basically exec another bash inside of bash with a specific, I want to say it's a PR or CTL command, but I don't know it, so I'm not going to pretend I do, to disable ASLR. But yeah, you spend a lot more time here trying to find the vulnerability. That's where your pain is for this module. Okay, very last thing here was an interframe. Let's go back to 8.0 because it already prints the stack, right? Conveniently. An interframe overflow. So if I give this thing a bunch of A's, this is nice enough to print the stack out for me. Are my A's on the stack? They are. Okay. Let's see. How much of the stack is this showing me? So this is probably all just main. Why can I say that? Just I'm a wizard. It's just a guess. There's a rhyme and reason to it. So this is where my A's are getting written. It's a stack frame. So this is somewhere within the frame. And if I scroll all the way down, what do I see? What does this look like? Yeah, a canary. Okay, what happens at the canary? That's the end of the stack frame, right? So this should be my
Main frame.
saved RBP.
Saved on.
It's 0. Why? Because I'm looking at the stack frame of main. Saved RBP isn't used up in libc, which is what calls main, right? Make sense? And this is going to be the return address for main
Let's just start.
up inside of libc start main, right? That looks like the end of a stack frame. So it's really only printing out one stack frame. So this challenge probably doesn't involve intra-frame overflows. Maybe it does, but it'd be a little silly to only print out in the help text a single frame, right? Let's find, oh, there's a, what was it, interpreter loop? Info func. Yes. Let's break at interpreter loop. Do I get there? I do. Okay. So this doesn't have a lot of function frames, but there's at least two. What are they?
Interpreter loop.
Okay, interpreter loops 1, that's my current function frame, and then the thing that called interpreter loop, which is going to be main. So I have two function frames here. What happens if I do the old classic 100, give me 100 giant hex at RSP? This is going to look a lot like, am I thinking about this right? I'm printing down, the stack subtracts. Yes, we write up. Okay, I need more than 100 giant hex. Do 400 giant hex. I want a lot. All right. And so what I see here is that there's my A's. We go down. There's more stuff on the stack now, right? Because the programs ran a bit more. Somewhere down here is going to be my canary. Did I skip it? You find it? B, D,
D3.
3, 8. Okay, that looks like my canary. So this is the end of that function frame, right? There's going to be a whole, what is on the other side of that function frame? Mains frame. So what happens if I overflow? Not from here, or I mean, I start from there because that's where I happen to read. And I blow past this canary, I blow past this saved RBP, I blow past the saved return address, and we just keep cruising. Somewhere here, there's going to be another canary-looking thing.
Yeah.
Right here. This is the canary for main. This is the saved RBP, which apparently just has some garbage in it. Did I get that wrong? That's just garbage and garbage, isn't it? That looks like garbage and garbage. Did I miss? So maybe that's not a canary. But I can overflow beyond main's frame, or beyond the current function frame into main, and target not the return address of my current function, but the return address of my next function, right? What is a problem that I'll inevitably run into?
Canaries.
So canaries is a problem. What else is a problem? We can just focus on this area right here, where I have a canary, a saved RBP, and then a saved return address.
You might override something that disrupts the control flow.
So yeah, if I'm targeting something in the next frame, I have to worry about the canary, but do I have to care about, is the saved RBP something that's same? Yeah, probably. Because if I mess up saved RBP, and then when it returns and it goes back to main, if main references something relative to RBP, I'll probably segfault. So I have to make sure saved RBP is whatever it expects. Do I have to care about the saved RIP that I'm blowing past? Yes. Why?
Because you have to come back from interpreter loop to main and then main to somewhere you want. So
Okay.
the first jump.
So the statement was, if I'm trying to blow past this and I want main to return, I have to get to main. So I need this return address to probably be what it already was, because I want this function to behave as normally as possible, right? Now, why would I want to do that? I don't know, right? An end example that I could think of.
I mean,
I can
write this table.
right. I could write to this return address. So why do I care about blowing through to? I don't know. Maybe there's some critical value inside of main that I'm trying to overwrite that goes to win, right? And so that's where that variable is stored on the stack. It's in the stack frame of main. A more complicated scenario that I can definitely think of is where was the return address of main, the saved return address? Where does that go to?
Libc.
Goes to libc. Where does the return address of interpreter loop go to?
Main.
It goes to main, goes to the elf. What if I want to partially overwrite into libc for something? I can't do that from the interpreter loop. I can do that from main. Not saying that's what this challenge asks for, or any of the challenges ask for. but something to think about, right? Why one would want to do that. With that, somebody else said that they do own the room. I'm over time. I'm calling it there. I appreciate everyone hanging out.